recall every element in the domain set. So here f is a function or mapping from A to B. Okay. Now we'll start one important topic in abstract algebra, mapping, or you can say function. So our first recall is f is a function from A to B. So just this is you consider as A, this is domain, and here it is basically say B, where A and B are non-empty set. So this A is called domain of the function, domain, and we can write it, note, dom of f, this is equals to A, where B is called codomain, codomain of the function. So codomain of f, this is basically called B, and A and B are non-empty sets, non-empty sets. Now we'll continue the important recall. Every element in the domain set. So there is another note. Every element in the domain set has image in the codomain set, has a image in the codomain set. So just you consider here x belongs to A and f is a mapping. So under the mapping f, the image of the element x is denoted by fx. So here x is called pre-image of fx, and fx is called image. So here our next note 1, note 2, note 3, x belongs to A and f is a mapping from A to B. That implies fx must be belongs to B. X is called pre-image, and fx is called image of x under the map f A to B. Now we come to the definition of the function. What is the definition? Recall the definition. For any two non-empty set, sets A and B, a relation f from A into B is called mapping or function, if the first condition is domain of f must be A. That means every element of the set A has an image in B. And 2, F is well defined. F is well defined. This is just the basic definition of mapping. Now we come to the say different kinds of mapping. So as for example, if we talk about the injective and surjective mapping, so now we are going to classification of mapping. Classification of mapping or function. So what is the classification? Under classification, there are many kinds of mapping, but while here I will discuss injective mapping and surjective mapping. Injective mapping, sometimes this is called, or you can say one-to-one mapping, one-to-one, or in some book you say one-one mapping. Another mapping is called surjective mapping. So surjective mapping is also called on-to map or this one. So now we come to the point, what is the definition of injective mapping? Injective mapping, we say a function or a map, if A to B is called injective, or one, if fx equals to fy, that implies x equals to y. And this is holds for all xy belongs to A. This is exactly definition of injective mapping. When you talk about the surjective mapping, so a map if A to B is called surjective, or you can say on-to map if f of A equals to B. What is the meaning of f of A equals to B? That is every element in the codomain set B must have a preimage or at least one preimage in the domain set A. So this is the definition of the surjective mapping. That means if we take this is our domain and this is our codomain, if you take any arbitrary y belongs to B, so there exists x such that fx equals to y for all y belongs to B. So this is the meaning of the surjectiveness. There is another concept, this is called the range of a map. Okay, so now we come to the important concept, this is called range of a mapping. So just you consider f is a mapping from A to B, then the range of f, this is basically all such fx such that x belongs to A. This is the definition of range of f, and this is always subset of the codomain. Now, if you see a range of f, that we can write in that symbol range of f. So range of H is proper subset of B, then the map is not surjective. What is the meaning? That is, there exists an element x belongs to B such that x has no preimage. Next is, if range of f equals to B, that means it is basically talking about the surjectiveness. That means every element in the codomain set must have a preimage in the domain set. Okay, so sometimes is confusing. The range of f equal to codomain or not. Okay, it may not be equal or it may be equal. If in the surjective case, range of f must be equal to the codomain set. But for the not surjective case, it is a proper subset of the codomain set. Now we come to the important example. So here our first example, or example 1, is basically you have given a function f set of real number to real number defined by 3x plus 4. Fx equals to 3x plus 4. Our first question is examine if fx is injective or not, 1 1 or not. And second question is examine if fx is surjective or not, So now we come to the solution, how to check that function is injective or surjective. So what is exactly given here? Here the function f r to r is defined by f of x equals to 3x plus 4 for all x belongs to R. Okay, now we'll check it will be injective or not. In the first case, so just we have taken, let x comma y belongs to R, R is their domain, be such that fx equals to fy. What I will show, if I will show fx equals to fy, that implies x equals to y, then we can write f is injective. So fx equals to fx means 3x plus 4, fy means 3y plus 4. So what it implies? 3x equals to 3y, and that is x equals. Therefore, what we have seen, fx equals to fy, that implies x equals to y for all xy belongs to R. Why? Because since x comma y belongs to R are arbitrary. Okay, so what we prove, f is injective. Thus, if R to R, that function is injective. Now we come to the surjectiveness. Injective on R, set of real number. Now we will prove it is surjective or not. Okay, so second part is talking about the surjectiveness. So we have to check every element in the codomain set. So this is our domain R, say this is codomain R, and our map is F. Okay, we'll say every element in the codomain set. We'll take y belongs to R, y has a preimage. We have choose our arbitrary y belongs to R. R is here basically codomain. We need to show the f of what x, it will make the R. It will be y. Okay, that we need to determine. So we'll do a rough work here. So as for example, say f of some x equals to y. If we consider, so f of x, that means 3x plus 4 equals to y. So what will be your x? X will be y minus 4 by 3. So that we'll put here. We'll put y minus 4 by 3 here. So that will be 3 into y minus 4 by 3 plus 4. So that means y minus 4 plus 4. That means y. So now you just see the f of y minus 4 by 3, that is equals to y, where y minus 4 by 3 is basically a real number. So that means since y belongs to R, so this is basically codomain is arbitrary. So every element in the codomain set must have a pre-image in the domain set R. So this is basically domain set R. That means F is surjective. So therefore F is surjective. Now we have a general question. A linear function is injective or surjective. That means you have given a function f R to R by fx equals to in that pattern ax plus b, where a is basically non-zero and a comma b are real number. The question is it surjective, injective? Answer is yes. Okay, the function f R to R defined by fx equals to ax plus b for all x belongs to R. This function is injective as well as surjective. Now we will come to another important recall. If we see a function f a to b, this is injective as well as surjective. If then we call f a to b is bijective. Okay, so if it is bijective, then hence we conclude f is invertible. If a function is invertible, that means f inverse b to a that exists, and also f inverse b to a, this is also bijective. So inverse of a bijective map is also bijective. Now we come to another important question. Examine if f is a function from R to R is defined by f of x equals to x square. Okay, for all x belongs to R, is injective and surjective in R. That we need to examine. So what will be our solution? Our solution for injectiveness, we will check it is injective or not. So just to think about, you will draw the graph fx equals to x square. This is basically graph for fx equals to x square. Okay, so this is x and that side is basically fx. Now we'll see if we take the point 1 here and minus 1 here, and you will see the same height. Or if you take 2023 here and minus 2023, or 2024 again minus 2024, they have gives the same value. So we take 2 points 1 and minus 1 both are real number and both are domain set. Okay, but when we are talking about now what will be f of 1? F of 1 will be 1 square, that means 1. And f of minus 1, again minus 1 whole square, this is basically 1. So what we have seen? We have seen f of 1 equals to f of minus 1, but 1 not equals to minus 1 in the domain set R. So that means thus f is not injective. Okay. So if we see note or recall is if x comma y belongs to A, we such that fx equals to fy, but x not equals to y in A, fx equals to fy in B. So that means if A to B is not injective. That recall is we have used in that case and we proved that f is not injective on R. You can take 2 minus 2, 3 minus 3, 4 minus 4, 100 minus 100, no problem. In all cases, you will show that two elements have the same image. So this is your domain A, this is your codomain B. Here you have seen two elements have same image. Here you have taken 1 and minus 1. The image is basically 1. So if we see two elements, there exist two elements who the image are basically same, but elements are different. In that case, we can conclude f is not injective. Now we come to the surjective part. Okay, now we come to the surjective. For surjective part, if we again draw the graph, if you take any number which is negative, okay, so what will happen? The negative number have no preimage. So as for example, if we take say minus 2 belongs to R, here R is codomain. Okay, codomain. It does not cut the graph. So clearly it is very clear. So clearly minus 2 belongs to R. R is codomain set, has no preimage in the domain set R. The domain set R. Okay. So here your domain is R, codomain is also R. If we take the minus 2, you have no preimage. Why no preimage? Because as there does not exist any x belongs to R domain such that f of x, that means x square equals to minus 2. This is not possible. Okay, not possible. That's why we are saying here the minus 2 has, we know, element of every real number, the square of an real number must be greater than equals to 0. As x square is always greater than equals to 0 for all x belongs to R. So that means what we conclude? We conclude if R to R, this is not surjective on R. Okay. So what we have proved? F is neither injective nor surjective on R. Okay. So maybe you have asked this kind of MCQ type question. Let f R to R be defined by fx equals to x square for all x belongs to R, then which of the following is or are true? Option A, F is injective but not surjective. Option B, surjective but not injective. Option C, injective as well as surjective. As well as surjective. And option D, neither injective nor surjective. So neither injective nor surjective is true. But here important note, if the codomain is restrict, that means if F is a mapping from R to close to 0 infinity, we define by Fx equals to x square. Then F is surjective map. Surjective but not injective. Okay? Because on that time every element in the codomain set must have a pre-image. Now we come to next important question. Straight true or false? That question has been asked in CU. Straight true or false with justification. With justification. What is the question? If Z star with a set of all non-negative integers and f is a function from Z to Z star is defined by fx equals to half x plus mod x. Then f is bijective mapping. Bijective mapping. Okay, this question asked in Calcutta University, Calcutta Honors CU examination. So now how to solve this kind of question? So first we will write the given map. What is the map? Map is here if Z to Z star set of all non-negative integer is defined by fx equals to x plus mod x by 2 for all x belongs to Z. Z is the set of all integers. Okay, now we are trying to check. So this is your Z and this is your Z star. So maybe just 0, 1, 2, 3, 4, 5, 6 and so on. This is minus 1, 0, 1, 2, 3, 4, 5, minus 2, minus 3, minus 4 and so on. When we come to the first, we will take say minus 4. Say 0. What is the image of 0? The image of 0 is 0. 0 plus 0 by 2. What is the image of minus 1? So again the image of minus 1 is minus 1 mod. So again the image of minus 1 is 0. The image of minus 2, this is also 0. So here you have seen the different element have the same image. Okay. So that means f is not injective, or that means it is not bijective. So we see that f of 0, this is basically 0 plus mod 0 by 2, this is 0. And f of 1, this is 1 plus f of minus 1. F of minus 1, so minus 1 plus mod of minus 1 by 2, again this is 0. So therefore what we said, f of 0 equals to f of minus 1, but 0 not equals to minus 1. And hence we conclude f is not injective. If a function is not injective on Z, that means it is not bijective on Z. So hence, f is not a bijective map on Z. Okay, so statement is false. So our statement is false. This is our justification. Why the statement is false? So this is our answer. Statement is false. Justification is like this.